Okay, so just a simple instruction video, just the test that I've made briefly this afternoon with the LJV 7080 head. This is a 80mm standoff. It's projecting like a laser line across the target. I'm going to link this back to the controller, which is this unit here, and this is then going to do the processing and create a 3D image. So first thing, we just give it a start signal, which I'm just going to do now. Then index the head over the part. We generate this 3D image, which you can now see on the display over here. Once we've generated this image, then we can start to make the program. So I'm just going to quickly just OK this. We can register this as like our master workpiece. So we just register this image in here. Just click OK. I'm just going to close this. Sorry, I just had something else set up there. Next thing we do is just to inspect the object, click Add Tools. So we just add tools over here, and then obviously this is related to our height information. So we've got standard height, trend height, profile measurement, or in this case we want to do a trend continuous profile measurement, basically looking across the trend. And an example here, actually very similar to the part that we're looking at here. So just click Add, and just default inspection region is a rectangle, but I'm just going to change this to a rotational rectangle just to allow me to position it a little bit more easily. Then we just select this over the area that we want to focus on. We could change the shape again here to suit really. So I'm just going to just make that a little bit wider, actually, something like this. When we're happy with it, just OK. And then you can see the profiles appeared at the bottom here. This is actually relative to this profile position here. So I can drag the pointer down, and if we look at the wide point, you can actually see there's a little spike in the middle. And if I just go back to the profile, maybe you can see right in the middle of the profile here, there is indeed a little spike here. So that's the point that we're actually looking at right now. So first of all, we need to just make what we call a zero plane specification. So we're just defining the plane as we want it to be, that we want to measure from. So in this case, I'm going to, just for ease of use and simplicity right now, I'm just going to do like a best fit region. So I'm just going to ask it to get me like a plane generated from this type of region here. And then maybe we can add on some offset just to make sure we're just pulling above any sort of noise in the background. And then this is the profile. If we just go back to like a good profile where we can see what we're looking at, get the nice bead profile here. Then just one other point we could add on just to eliminate any noise or missing point. We can just add on this invalid pixel suppression. So as it says here, this just uses the height data and estimates like surrounding valid pixels. So if there's some missing data, it can add that data back in basically. So just accept that, okay. And then down here, this is the measurement item sort of list. And we just add from a choice of different options what we actually want to add into the menu. So we've got the profile measurement. So the one I'm just going to look at initially here is just maybe like a cross-sectional area. So let's just add that in. And then we specify like the area that we want to take the measurement. And you can see at the moment, this is actually measuring below the datum line. So the white line here is the datum line we just added in. It's also measuring below and above, and then measuring the cross-sectional area of whatever is above and below. So I just want to take into account really just the convex part, just this area that's above. Maybe just widen that a little bit more. And you can see the two X's here indicate the width of this this box. So if I drag this out as far as we want, just to make sure we're going to encompass the larger sort of bulge right down here when we get to that point, maybe like this. And then we can put some lower limit here. So let's say lower limit, let's say 1mm squared, just for now. And then finally, just number of no good profiles. So I'm just going to say, obviously I don't want to see any no good profiles. And then that's pretty much it. So now we're inspecting this area. Every slice of information is being inspected as we scan down that profile. And you can see at the moment, actually 74 profiles, and all of those are within the good range. Total cross-section area is 38.5mm squared, and each slice is 3.3, so that's where we're at. Thank you very much. Cheers.